All right, I got 3 o'clock, so I think we'll go ahead and get started. Thanks again for everybody coming to the last session of the day. You came to see me. I hope everybody has enjoyed the session and the conferences so far. I've had a great time here in Poland. We're going to talk about banishing slow queries with intelligent query processing. My name is John Morehouse. I am a principal consultant with Denny Chair Associates. Essentially, I'm a really big nerd. I do a lot of things in the data community. My contact information is on the slide before you. Feel free to reach out to me via email, LinkedIn. I'm on Twitter. Twitter is about the only social media platform that I'm actually on anymore, and even that's kind of limited. I will say that SQL are us, not SQL Russ. But SQL are us like Toys R Us. As I said, I live in Kentucky in the United States. Yeah, that's basically me. Quick blurb about who I work for. We're a small bunch of IT nerds that like to solve business problems using usually SQL Server or Microsoft products, but we like to do things in data. If you're looking for a consultant to help with a project, hit us up. My slides, and I've got a couple demos, but all my slides and my demos are actually on GitHub. If you go to bit.ly, my presentation files, you will get them. I just published them like 15 minutes ago. So the slide deck that is out there is live if you want to follow along, especially for those of you that are online. You're welcome to do so. So we'll go ahead and continue. Oh, thanks. Not quite. Not quite. Last session of the day, I was going to try to see if we could get some jokes going. If anybody noticed, I'm actually running Macintosh, so I wouldn't get a blue screen to death. Sponsors, doing conferences like this, especially a multi-day conference, takes a lot of volunteer hours. I know that we're ending and winding down, but if you have time and you haven't done so already, go thank the sponsors. Go find a volunteer, find an organizer. You had a great time. Tell them thank you because they put a lot of time and sweat and tears into putting the conference on for us. What are we going to talk about today? Here's a quick agenda. We'll talk about what is IQP. My colleague, Joey D'Antoni, did a session on advanced query processing, which was the birthplace of IQP yesterday. So we'll kind of go back over what it is. We'll talk about some challenges that kind of, in my mind, is what brought AQP and IQP out and some of the things that it solves. We'll talk about the table deferred compilation. This is a feature that actually came out in SQL Server 2019. Joey yesterday talked about mostly 2017 features, so I'm going to touch on this because I think this is important, especially from a 2019 feature. It's super important how to fix some performance issues. We'll talk about a 2022 feature called parameter sensitive plans, and then also a 2022 degree of parallelism feedback. Those last two are all 2022 related, but really this is all about making my life easier, so I think they're really important to at least know and be aware of. These are actually two features that I have, in my mind, is a reason why you should look at going to 2022. Because I think it'll help with your performance, it'll make things easier. And as I said, originally, IQP started off as adaptive query processing in SQL Server 2017. Much like Prince, they rebranded it into IQP in 2019, and it's remained IQP since 2019 and moving forward. And you're right, you need to drink water. So if you see older features, you'll see AQP reference there. And really, one of the things that I think came out from a challenges that we perspective, how many of us remember before more modern versions of SQL Server, in order to make changes or enhance performance, you couldn't touch the application? I used to run into that all the time. I would have management or app dev developers come to me and say, hey, performance sucks. We have to make this faster, but we can't release any code changes. We can't fix the entity frameworks or the ORMs. We can't recompile the code and redeploy it, so you have to do magic on the database side to make things better. And you would spend hours and hours trying to figure out, rewrite the query, change an index. You would do various things to get that performance better, but this was always one of the balancing acts as DBAs that we used to face in earlier versions of SQL. At least I did. Almost every single shop I went to, they were like, you can't make it run faster, but you can't change the code. That's difficult. Now, Microsoft, I think, listened, and they said, we got you. We're going to take that challenge up. And thus, adaptive query processing was born. These features really help us to enhance performance without doing any major intrusive changes to your overall application. IQP, I can enhance and make your performance better without changing a single line of code, potentially. I don't have to deploy an application. I don't have to make an entity framework change. I don't have to make any changes other than maybe enabling a feature on a database. So these features really make my life as a DBA, and your lives maybe as DBAs or application people, a lot easier because we can make performance better without doing a ton of code changes. And part of the challenge that they accepted, and they had to figure out ways to start gathering metrics on your queries so we can start to get some insights, right? If you attended my colleague's session earlier, she mentioned Query Store. Query Store is part of that. Query Store is super important with intelligent query processing. But we got some new things that came out when they started with this in 2017. The first one is a lightweight query profiling capability. If you remember in versions prior to 2017, you might have to query the execution cache to actually find queries that are running poorly, excuse me. And so we didn't have a really good way to start getting metrics as to what was actually running at that point in time on your SQL Server instances. So they released this lightweight query profiling feature. It's actually a database scope configuration in SQL Server now. You can turn it on and off. But this lightweight query profiling now gives us better insight as to what's actually running. It provides that framework for the performance improvements. If you're on 2019 or less, how many people are running 2019 or lower? Yeah, most everybody still. For those that are at hand, probably 75% of the room are 2019 or higher. Anybody running 2022 currently? Oh, there's actually 4 or 5 people running 2020 in production. Oh, fantastic! I would love to hear your feedback on how it's going after the session. If you're running lower than 2019, you actually had to opt in. It's actually a trace flag that you had to enable, 7412. So if you wanted to get that feature, you have to turn on that trace flag, 7412, bounce your instance, and then you'll get that lightweight query profiling feature. I say Query Store is utilized in most cases. There are some cases where Query Store isn't used. If you're not using Query Store, though, I highly recommend it. If you're not aware, Query Store, released in 2016, SQL Server 2016, is literally the flight recorder of SQL Server. They give you a graphical interface to identify where your queries are performing poorly and ways to fix them. There are some IQP features where you don't necessarily need Query Store, like memory grant feedback, unless you're using the 2022 features of persisted, where you then do need Query Store. But I highly recommend Query Store anyways. This is actually the roadmap that you will probably see on Microsoft website. I love their coloring choices because they actually reversed the colors. But in 2017, they released the light blue, which is the adaptive query processing, and we had some great features that came out of it. Memory grant feedback is one of my most favorite features. If you attended my colleague Joey's sessions yesterday, he demoed that where SQL Server will actually adjust on the fly how much memory a query is going to utilize. And then out of 2017, we came out with 2019, which is in the white. I really wish they had reversed the color schemes here. So they rebranded AQP into IQP, and then we got some more features, such as table variable deferred compilation, batch mode for row store, row mode, scalar UDF inlining, which is great. And then the team said, we still got you. We're going to go to 2022, and we're going to release even more features that will help enhance performance without doing hardly any code changes. And because I'm a lazy DBA, I really like that. It makes my job easier. Now, the one thing, I said Query Store is not always needed. One of the things that Microsoft did when they started to release these features, and I don't remember exactly when they changed it, 2016, 2017, but a lot of these features are related to which compatibility level your databases are running. So back in the day, Microsoft would certify applications and whatnot on what version of SQL Server you are running, right? So your application vendor might say, this application is only certified to run on SQL Server 2016 because we haven't tested SQL 19 or newer versions. That was always a pain. Microsoft said, well, that's kind of dumb. We're going to start certifying things based off what compatibility level you are. So I can run a database in 2016 compatibility, but on a 2022 server, and Microsoft will certify that it will function as it was running on 2016. These features are related to the compatibility version. So if I want to run the IQP 2022 new features, I have to be in the 2022 compatibility level, which is 160. 160 is to SQL 2022, 150 is 2019. Thankfully, it's an easy change. It's a database configuration. You can just flop it back and forth if you so desire. But it's super important to know what your database compatibility levels are to ensure that you get the right features. Okay, so if you go back to your environment, you want to play around with the new features, make sure you're at the right version of the compatibility level. Along with adaptive query processing, we're starting to see more things that'll come out of like the dynamic management views that gives us more insight. We get more data to play around with to understand what the how our queries are performing. So if you are in 2016 SP1 or higher, we actually have a new DMV, DMX query statistics XML, where you can actually pass in a session ID and actually get the execution plan out. That's in flight. And then once it completes, we can also get the actual execution plan out of the DMVs. Before this was introduced, you could get the cached version, but if I remember correctly, the cached version was the estimated plan, not the actual. And so the only real difference is the plan shape should be the same, but you don't get actual runtime statistics out of that estimated plan. Now we can. We have a new DMV, DM exec query plan stats, where you pass in a plan handle, and then we actually get the actual last executed execution plan from that lightweight query profiling. Okay. As I mentioned, the last query plan stats, you have to enable that to get these two, but that's a database scope configuration, so you can set it on a per database level if you want. But you can start to query and mine those execution plans or these DMVs to actually get your actual execution plans. Okay, again, query store. Yes. 4712. Yeah, this one's on by default moving forward. Yeah, after 2016 SP1 or higher. Yeah. Okay, so Erlen said the comment was that in order to get to this top one, you have to have 47 trace flag 4712 on 16 and 17. Okay, I'm not sure I knew that, so thank you. Yeah. Okay, so first up, we're going to talk about table deferred compilation. This one has always been an issue for me working with previous versions of SQL Server. Joey yesterday did not mention this, which is really good because I didn't want to repeat the content. But in olden days, how many of you use table variables in your code, your store procedures? So about half the room. Okay, that's cool. The problem with table variables today, if you're not using 2019 or higher and have this turned on, is that you would get an estimated number of rows to be 1. So it doesn't matter how many rows you have in the table variable. If you populate that table variable with 1 row or 5,000, doesn't matter. SQL Server would always estimate the row count in there as 1. That causes problems because if you have a very large data skew, it didn't function well. So in 2019 or lower, we have that 1 row fixed estimate, as I mentioned. Too many rows. If there's too many rows, we get a bad execution plan. Has anybody heard the best rule, or the names of the words are escaping me? Best practice, sorry. If you have a high number of rows to work with, use a temp table. If you have a low number of rows, use a table variable. Anybody ever hear that best practice? My rule of thumb as a DBA is if you want to play around with more than 1,000 rows, put the rows in a temp table. If you are using less than 1,000 rows, put it into a table variable if you want, because of this very reason. Because I can get a better execution plan because I have a lower row count in my table variable. Your mileage may vary, your business case may vary. As a rule of thumb, though, that's kind of where I start. 1,000 rows. Others might have other thresholds that will work, right? So in 2019 or lower, I get this one row fixed estimate. And this is why I like table variables versus temp tables. But with 2019, when we released it and we can turn on this feature, we now have a difference in where the compilation of that table variable actually occurs. So instead of estimating one row for that table variable, we actually shift that compilation to the first execution of the query. And so now we're getting better numbers out of the table variable, which means that we get a better execution plan. We get a better performance of our query because we have a better idea as to how many rows are in there. So we get a better cardinality instead of SQL Server just saying it's one, it's always going to be one, doesn't matter what you do. Right? So I'm getting better performance. Again, I'm not going to make any code changes. I'm going to turn on a feature in a database and I'm going to automatically get better performance, right? And so this actually allows us to kind of get a mimic of more temporary table behavior because now, again, we can get better statistics on that table variable. So instead of having to rewrite all your code, for those that raised your hands about using table variables, just think about how difficult it may be to go rewrite all that code to use temporary tables versus table variables. In my head, especially some of my clients that I deal with, that's a really large undertaking. With this feature, with 2019 and enabling this feature, I don't have to do that. I can just turn it on and their code is magically delicious and it works. And I get better performance and my clients get happy. Any questions about table variable deferred compilation? I got a couple demos. We'll go through a demo when I get toward the end. Parameter sensitive plan. I will probably mess up saying this because I'm going to say it like quite a bit in the next slides, so I will apologize up front. Who has ever heard of parameter sniffing? All right, so recap. So parameter sniffing, some people will tell you that parameter sniffing is bad. It's not. That's the way SQL Server is designed to work. This helps fix parameter sniffing. Now, parameter sniffing happens when a parameter value that comes in for a query, an execution plan is generated. That execution plan works great for the first initial value. So let's say the store procedure gets a value for an ID of 3. The execution plan works great for the value of ID of 3. And then we get a subsequent execution where that parameter has a much larger data volume. Parameter sniffing usually happens when you have a very large difference in data volume because the initial execution plan doesn't work well for that given secondary ID, right? So one plan might need a seek, but the other plan, because we want to scan 20 million rows, that seek is not going to perform well, and so therefore we get a parameter sniffing issue. And how do we fix it? Recompile is a great, if I had swag, I would give it to you. I don't have any swag. In the olden days, before this feature, there were ways that we could fix that parameter sniffing issue. We could do recompile. You could, if you had a store procedure, you could trick, I don't remember the trick exactly, but you could redeclare the variable and set the variable to the value that was passed in. That was always a trick that we always worked with the people the places I used to work. But even with that, we had to make a code change. We had to change the code in order to fix that problem, and it wasn't always a guarantee. Has anybody ever tried to warm up the execution plan after a reboot? Before I was a consultant, and many organizations I would work with, parameter sniffing would become an issue. And so we actually had multiple cases where we knew that if the wrong parameter was passed in, a bad plan was generated. So the DBAs got sneaky, and they actually, every time they rebooted the SQL Server, they would run the execution with a specific parameter to make sure the right plan was generated to avoid parameter sniffing. So they had to trick SQL Server to, as soon as it started up, startup procedure would run with the right ID, we'd get the right plan, everything was great until that plan aged out of cache for some reason. Somebody ran system free proc cache, don't ever do that in production, don't drop your production cache. And then we had to go figure out which, go do it again, run it, drop and then rerun it with the right parameter. Parameter sensitive plan helps fix that issue, right? And I think it's a really cool feature. I think it's really smart in terms of how Microsoft has developed it. Right now, it only works on equality predicates. I don't know if they're going to expand that on inequality predicates. But if you've got code right now that are using, where column 1 equals something, it only works on equality predicates right now. These cardinality values for the parameters are essentially divided into 3 different buckets. If you attended Joey's session, if you attended my colleague Monica's session, one of the things that overlaps for both of their sessions is statistics. If SQL Server is going to determine what values to put in these buckets based off cardinality, statistics is super important. Out of anything from my session, her session, Joey's session, maintain your statistics and maintain them well. However you need to maintain them. Ola Holmgren's stuff is rock solid, really like his code. But maintain your statistics because it's going to depend on how those values are divided. And I've got a diagram that'll kind of workflow this to make this a little bit more easier. So out of those values, we actually get a high, medium, and low predicate values. Okay, and so those will dictate. In the demo I have, I actually only have 2 buckets, but in this, from the documentation from Microsoft, it says there's a high, medium, and low, and then we get 3 different buckets. So which means is that we can have 3 different variant plans for a query that is accepting a parameterized value. Once it finds those high, medium, and low values based off your statistics, it'll create those 3 child buckets, and those are basically called variant plans. They are compiled and executed. They also have their own execution plan in Query Store. We can now see some of those variant plans in Query Store. So again, if you're not using Query Store, super important. We also have what's a new object called a dispatcher plan. That dispatcher plan is actually what controls how the buckets get divided. And so as the new query comes in with a parameter, the dispatcher plan will pick it up and say, hey, your parameter is a value of 3. The value of 3 needs to go over to this bucket. That bucket has a different execution plan for the value of 3 than what the other 2 buckets might have. Does that make sense? How about if I just get you a picture? So the dispatcher plan will be recompiled after large data changes. The variant plans will be recompiled independently. Because we can actually see these plans individually in Query Store, they are kind of their own unique thing, but they're all linked together in the same family of features. This will probably solve things. It is really dry. This image is from learn.microsoft.com. And they've got the documentation on Microsoft is actually pretty decent in my opinion. But if we have this original, that's not going to work. I thought that was a laser pointer. Up top, you can see the parameterized query. So that's what I call the parent query. So that's the initial query that comes in with a parameterized value. SQL Server identifies that query as one that can take advantage of the PSP feature. Once that query comes in, the dispatcher plan will be created. We can see we've got our 3 buckets basically over here. We have an agent ID with 20 listings, 2 with 76,000, and then 3 with 1.1 million. So to me, that's a pretty large data skew. But then we've got on the left query variants with agents with less than 10,000. So if I supply the ID or agent ID of 1 for my query, I would actually get a cached plan that has a seek and a lookup, which we should fix the lookup to get better performance, and a small memory grant. Whereas the other 2 buckets, you can see on the far right, we actually end up with an index scan, and a very large memory grant. All right, so we can actually now have 3 different execution plans based off what parameter we may or may not pass into the query. And remember, I haven't changed any code. So if you are experiencing parameter sniffing and you're not on 2022 yet, this should probably interest you. Because you can move to 2022 and enable that feature and potentially solve your parameter sniffing problems, okay? Out of this, we actually get 2 new DMVs in the Query Store. Query Store _query _store _plan, and then query variant. So again, we can actually interrogate, and if you are a nerd like me, I actually have gone into the query store, and we'll actually look at it when I do the demo, and we can actually see those plans and see how they function. Okay. Any questions around PSP? You all are quiet for the end of the day. Everybody tired? Okay. Degree of parallelism feedback. This is another feature that I think is a phenomenal thing for Microsoft to introduce. Anybody ever mess around with the maximum degree of parallelism for your SQL Server instance? Yeah, ooh, yeah. Somebody's getting gutsy and changing things. You should, right? Parallelism is a good thing. I think it's a great thing. One of the problems with the degree of parallelism, though, is that it is not a one-stop shop. Usually, the rule of thumb is if you have an OLTP workload, transactional workload, you start with half the number of cores up to 8 cores, and you start with a number of 8, and then you adjust as you go. If you have a OLAP workload or data warehousing, you start at like 2 or 4, depending on what your workloads are, and again, you adjust as you go. It's never a set it and forget it. That's a U.S. reference to Ronco. You don't just set it and don't ever go back and look at it again. Much like indexing, cost threshold parallelism and the maximum degree of parallelism might need to be adjusted as your workload shifts. Your workload is going to shift because hopefully your businesses are getting bigger. You're selling more stuff. As you sell more stuff, your workloads get bigger and things change, right? Part of the problem is if you have something set with a maximum degree of parallelism, all the queries are going to function under that same model. There are query hints that you can use to kind of adjust things. Usually those were edge cases. Maximum degree of parallelism, though, the DOP feedback, we actually use Query Store to identify the elapsed time and waits to identify inefficient queries based off that maximum degree of parallelism setting. So SQL Server keeps track as to when you run a query, what level of DOP did we run it at? 2, 4, 6, 8, 10, whatever the case may be. If you ever look at the XML of an execution plan, you can actually see what that value is. So Query Store now tracks that. So now we can get metrics on it. And SQL Server can do something with it. Query Store is required for this feature. You have to have Query Store enabled to actually use this feature. If SQL Server determines that the DOP feedback that it's getting isn't good, the engine can actually revert the previous value. Now, some might say, oh, DOP feedback is going to increase my DOP. That's not the case. SQL Server will never magically increase your maximum degree of parallelism beyond what it's capable of. DOP feedback will only lower your DOP for a given query, right? And so that by doing that, we actually, and if you attended Monica's session, she mentioned it, DOP or degree of parallelism can affect your CPU and your I/O. So by lowering their DOP feedback for a given query, we get better CPU and potentially better throughput of our queries. If you see a plan regression, the only thing it's doing is actually reverting to the previous value. If in Query Store you have ever messed around with plan forcing, so one of the most beautiful features of Query Store is that you can force a plan. So if you are examining 2 execution plans and one performs better than the other, you can actually highlight the better performing plan and click Force Plan, and SQL Server will continue to use that better performing plan moving forward. I have solved countless client issues by going into Query Store, and they give you a nice interface. You look at all the pretty graphs and you go, oh, that performs a lot better, force. And the clients go, holy smokes, John, you're smart. Not really, I just looked at a paragraph and hit a button. It's really great. If you haven't looked at Query Store, it's fantastic. In this case, if you force a plan, DOP feedback will honor that, okay? So if you are the DBA, the data professional in Query Store, messing around and forcing the plan, DOP feedback will honor that. This is kind of how it looks. This also was taken from Microsoft, knowingly, like they provide this to use. The link is down below. If you ever want these slides, this picture, you can go to that link in the very bottom and get it. So here up the top, we actually have a SQL query that comes in from an end user. That query comes into the query processor. The query processor identifies it as, hey, we want to do some DOP feedback on this query. We want to see if we can optimize the degree of parallelism for this query moving forward. Using query stats and query store, we're going to go over to the query store background task. Is that query eligible? Yes, we're going to move forward. We're going to start to do analysis on that query, and we're going to start to provide feedback. That feedback then goes back into query store. We're going to validate that feedback, and then we are going to either make it stable, we're going to revert it, and then give feedback, and then DOP feedback to the query store, and then keep going around and around. My demos, that's the only demo I can't do because it takes 30 minutes. Because this feedback loop takes 30 minutes to roll through, and so I decided that I didn't want to make you all suffer through the 30 minutes because that'd be really awkward. But I've got screenshots of what you can see. The other thing that came with DOP feedback is we actually have new extended events. If you like extended events is a lightweight mechanism to do some pretty thorough analysis of things. There are actually DOP feedback now in extended events where you can actually, and we'll see it in the demo because that's one of the ways that we can see what that feedback is. The screenshots I have will actually see that DOP feedback lower, but it takes 30 minutes. And then we just keep going round and around until we get to a final stable plan where SQL Server has lowered the degree of parallelism from the initial value potentially all the way down to 2. Now, 2 is the lowest it'll go. It won't rotate up unless it's reverting. It'll go no lower than 2 because that makes sense. Because if I had a degree of parallelism of 1, am I going to go parallel? No, I'm not. So it makes sense that the engine is not going to go any lower than a value of 2. So it's not going to go any lower than 2. If you are using query hints to specify a degree of parallelism value, I personally do not tend to use query hints. I'm not smarter than the optimizer. But if you have a query hint of a higher value, DOP feedback will use whatever you are hinting on that query as the starting point. So if you have a specific query that might not be following the defaults, but you've set that hint to a specific value, that will become the new ceiling. Obviously, it's not going to rotate up anywhere. It's just going to continue to lower it down, even though you've said, hey, I want you to use this DOP feedback or this degree of parallelism for this specific query. DOP feedback can still try to lower it based off the metrics, okay? Anybody using availability groups? Yay. Love availability groups, are great. DOP feedback is replica aware, which makes sense because it's stored in query store. Query store is replica aware. Anything that's in query store gets transmitted over to the secondary. So if you're using availability groups, you can use that DOP feedback on the replica on your secondaries. So it is there as well. So which is really cool. Any questions around DOP feedback? You all see some stuff? Cool. All right. So I've got a couple demos. You weren't supposed to see that. Okay. And what I've got is, can everybody see that? Okay. Everybody in the back? A little bigger? You want the font bigger, Erland? That's fine. Better? Good? Okay. So what I've got here is I've got a VM in Azure. It's running the latest and greatest of SQL 2022, so I'm in 16. The build is 16. I've got a wide world importers database. If you go out to the QR code that I provided for my session files, the slide deck and the files, there is a link out there to a copy of wide world importers that is pre-staged. In order to do the PSP feedback demo as well as the DOP feedback, if you want to play around with them, you have to populate a very large density difference. And so, like, one of the tables in the database has 20 million rows. And depending on what your workload is, it might take you a while to populate 20 million rows. But I've got a link to a Dropbox that you can go download the backup file, so you don't have to do that. But first, we're going to look at table deferred value compilation. I'm going to use wide world importers, and I'm going to create a procedure, sales customer profits, that is going to utilize a table value valued parameter. I'm going to set my compatibility level down to 130, which is equivalent to 2016. So if you remember that compatibility levels are important with these features, and so I'm going to tell SQL Server run this as it was sitting on 2016 where that feature does not exist. I'm going to turn on actual execution plans, and then I'm going to run that procedure. Now, thankfully, my VM in Azure is relatively beefy, and it's got nothing else running on it but this thing. If we look in the second execution plan down here in the lower right, I'm going to zoom in, there is a temporary table here. And if we look, there's two things here. We get a clustered index scan, but we can actually see that my estimated number of rows is 1. So regardless of how many rows are in that table variable, I get 1 row. Doesn't matter, right? And this just verifies that what we know to be true. If you're below 2019 and don't have this feature enabled, we get that 1 row of 2. Doesn't matter what we do, right? So if I come down and then change my compatibility level to 2022, in this case, I could do 150, which is 2019, and rerun this if my mouse will work. Now, the one thing I didn't look at was the IO stats, but the important part is, one, the plan shape. If you notice, the plan shape is a little bit different in the second one than the first. And I still have on the far right there is my clustered index scan of my table variable, right? We can actually see we've got 228 rows out of 228, so 100%. So my stats are pretty good. But if I highlight and hover over this, my row count is different. Now, for those that are using table variables, what would you think about changing, just enabling the feature in 2019, and your performance magically gets better? And did I make any code change? Everybody should be shaking their head. I didn't make any code changes. All I did was change the compatibility level from 2016 to 2019 and reran my code, and I get a different execution. I get a different cardinality estimation out of the table variable, and I get a different execution plan. So potentially, your mileage may vary depending on what your workloads are doing. I'm getting a better execution with doing nothing, okay? That's a really simple demo of table valued deferred compilation. Any questions on that? Cool. I think I'm on pace to get you out of here early. So let's look at PSP. So remember parameter sensitive plans. It's about solving the parameter sniffing issue. So one of the things I'm going to do is there's a store procedure I'm going to create. Did that increase? Okay, I'm still at 200. Cool. Let's do this. I'm going to create a procedure, warehouse get stock items by supplier. And so I'm going to pass in a supplier ID. We can see it's defined there in the execution plan. So my supplier ID is important. I'm going to use wide world importers again. The other thing I'm going to do is I'm going to rebuild this index. Index rebuild is going to make sure I get really good up-to-date stats. I should only take a few seconds, hopefully. And then once that's done, I'm going to alter the database to set the compatibility level to 160, which again is 2022, just to make sure I'm at the right one. I'm going to clear the procedure cache for that database, and then I'm also going to clear the query store, just to make sure I don't have anything, remnants from me like testing. I've been testing things for the past couple days. Now, if you're not familiar with the newer versions of SQL, one of the things that Microsoft has done recently in the newer versions, and I think it's really smart, is instead of having server-wide configuration settings, now you can change things for a given database. So if you can look, there's a DMV called sys.database scope configuration. These parameters and these features are enabled on and off for a given database, not server-wide. I think that's really smart of Microsoft because it gives us data professionals a ton more flexibility, right? So I was just showing you here that my parameter-sensitive plan optimization, the value is 1, meaning it's enabled, as well as my DOP feedback. If I needed to, I can turn these off. If you have a workload that this might cause problems with, you can go into that specific database and turn those off if you wanted to, okay? I was just showing that that's what that looks like. Now, the other thing I wanted to show was, because these demos are related to these statistics as well as data skew and distribution, and remember that my procedure for this demo is dependent on my supplier ID. Well, so let's look at the differences of the supplier IDs. 1, 2, 5, 7, 10, and 12 have really small counts. So if I am looking for small row counts, most likely a seek is going to perform better. However, if I look at a supplier ID of 4 that has 20 million rows in it, a seek is not going to most likely perform well. Most likely, I'm going to want to scan the entire table. So I need 2 different execution plans, right? So supplier ID of 4 has a much larger data distribution than all the other IDs. So I've created the store procedure. So I'm going to run this store procedure using a supplier ID of 2. So I'm going to pass in the value of 2. And here we can see my coworker Monica is going to yell at me because there's a key lookup. I get an index seek. Now, because it's a supplier ID of 2, the ID of 2 has a small row count. This is what I would expect. Right? I would expect this seek to be in the execution plan because that's going to be the most optimal for the engine to use to go fetch that number of rows. We can see that I fetched 3, and I hope I didn't just break the chair. And I could go fix the key lookup to make it even faster, right? Now, if I do a supplier ID of 4, how many rows did supplier ID of 4 have? 20 million. That's a big difference between 3. Here, I would expect a scan because I'm going to scan pretty much the entire table to get all 20 million rows back, right? Without parameter-sensitive plan optimization, what execution plan would it use previously? It would have used the seek. It would have used the plan from the value of 2. That's the good old-fashioned parameter sniffing where the initial execution plan isn't optimal for a different value that has a much larger data distribution, right? So if I run this, and I don't remember exactly, I'm going to break this chair. That'll be funny.
No problem, it's the last session.
Thanks, Erland. Yeah, she was before me. And I can't blame her. So if the thing works as it's supposed to, and the demo gods are on my favor, when this finishes, we can see that I've got a bunch of data, and that's the one thing I like about ADS, Azure Data Studio over Management Studio, is that Azure Data Studio actually will show you the row counts as it goes. Once this finishes, we'll look at the execution plan, but I should see a scan, which means that I've got a dispatcher plan, and I've got 2 query variants from PSP that has generated an execution plan with a seek with an ID that has a less data distribution, and then a second query variant that has a larger data distribution with a different execution plan where I get that scan. And I had it already up, and I clicked execute, and I should have just waited. So right now, it's querying all 20 million rows, and I'm not sure exactly what it's waiting on because there's nothing in that on that VM. Might be waiting for Management Studio, yeah, that could be. And the demo gods are not on my favor right now. Of course. All right, we might have to come back to that. We'll give it a second or two. All right, tell you what, we'll come back to that and I'll prove it. Everybody good? Cool, all right. Instead, let's go look at what DOP feedback looks like. Okay. Now remember, DOP feedback, this demo takes 20 minutes or about 30 minutes to run. We can actually see the time slots. So this is what you're looking at right now is the DOP feedback that comes back from the extended events. So if we look, and if I had my laser pointer set correctly, at the very top, we've identified that the DOP feedback is eligible at the very top with a feedback DOP is null and the query DOP is what it's set at. When I ran this, I ran it on a virtual machine that had 16 cores on it. SQL Server was set to a max stop of 0. Max stop of 0 tells the optimizer, says use everything you got, use all 16 to start with, and we'll go from there. Okay, so we started at 16, but then we could see as it started to go through that round robin, remember that picture I showed where we went round and round through the query optimization? We started to get feedback from the query optimizer where we're going to drop from 16 to 12. So we start at 12, we start to do some validation is 12 stable, cool. Then we go from 12 to 8, and we go again. We rinse and repeat this process. And I know that's really interesting from a guy that has no hair, rinse and repeat shampoo. But we keep going all the way down from 12 to 8, then 8 to 6, then 6 to 4, and then at 4 is where it stopped. You can't see it down below, or I didn't get the screenshot. But it took about 30 minutes. We started at 1:16 in the afternoon and finished at 1:45. So roughly 30 minutes to get to a stable DOP, degree of parallelism, of a value of 4. Now, why is that important? If you look at Query Store, so this is, if you're not familiar with Query Store, this is the Query Store interface that you would see. We can look, and this is at duration, average. This is the average duration for this query. We can see on the graph on the right that on the left, we started pretty high. And then as DOP feedback kicked in and we got a lower and lower feedback, my queries actually started to get faster. We took less duration, and we can see that line. I didn't draw the actual statistical line through the dots, but our queries got faster on average, and our CPU got better. So this is CPU time on average. And so as DOP feedback again got kicked in and we lowered all the way down to 4, we can see that our CPU time got better. So if our CPU time got better, that means that we can query more, we can process more queries faster. We can maybe sell more widgets. If we sell more widgets, we make more money. If we make more money, my raise is bigger. It's all about me. I want to make money. I get better performance because my individual queries are consuming less CPU just from enabling DOP feedback. Have I made an ounce of code change? No. Again, I haven't made any code change whatsoever. All I did was enable a feature and launched my queries, right? Really cool stuff. This is one of those features that I would go to management and say, this can help solve problems that we might be having in my environment. Can we look at going to 2022? PSP and DOP feedback, I think, are, from a DBA perspective, who's been around for quite a while, are game changers for me. It's like when they released Query Store. Query Store in 2016 was, yeah, really, really big stuff. All right, so let's go back and look at our... No. So great question. So just to repeat it, the question was, can you then forget about trying to set the maximum degree of parallelism at the server level and set it to 0 and then set it and forget it? The answer is no, because not every query is going to take advantage of the degree, right? And so the engine has to decide, is it eligible for this feature? And if it's not, you're not going to want, you could potentially cause another problem by doing that. So I would not do that. Yeah, I can't think of any workloads that I would want to do that with. Your mileage may vary. I would tell you to test that. But I wouldn't start with 0. I don't start with 0 anywhere. All right, well, let's go look at. Yay, finished. Okay, back to PSP, and I apologize for the delay. But we can see that I got my scan. I scanned all 20 million rows, or 19 million. I got 10 minutes left. Cool, thank you. I scanned all my rows, And so that means I've got that second query variant. We can actually look into Query Store. I don't think I have anything else there. Nope. If I look into Query Store, I can actually see, remember, there's a dispatcher plan, a query variant plan, actually 2 query variant plans. So I can actually look, if I click on that blue link and actually open up the XML, I can interrogate the dispatcher plan in my 2 query variants, right? So if I were to run this with another parameter that had a higher data distribution, I would eventually get 3. So right now you're limited to 3 different query variant plans. I would hope that Microsoft is going to extend this to maybe 5 query plans, so you have a better idea of your statistical data and your data distribution. I have zero knowledge if that's going to happen. Zero. I just think that'd be really cool if they could say, hey, instead of 3, we're going to do 5 buckets. We're going to do 6 buckets. That's a balancing act. I think that would be really cool if they did it, though. Any questions on this demo? Cool. So this was CPU time. Now, Microsoft wants your money. The table variable deferred compilation and the parameter sensitive plans are both available in standard. I love it when Microsoft gives us features in a cheaper product in terms of paying licenses for SQL Server, because enterprise licenses are super expensive. So these top 2 you can get if you're running standard. A lot of organizations are still running SQL Server Standard. Who's running SQL Server Standard? I got most of my clients are running standard. How many of you are in Azure, like Azure SQL Database or MI? Cool. You can take advantage of those both in Azure. Degrees of parallelism is limited to enterprise, and right now it's only in the box product. So if you're installing SQL Server 2022 in a virtual machine, you can take advantage of it. It is not available in Azure SQL Database or Azure SQL Managed Instance yet. I think there's a private preview of this. Yeah, I think they're looking for customers who want to use it in Azure SQL Database. So it'll come to Azure SQL Database. I don't know if it'll come to Azure Managed Instance. I think it will, but I know that they are actively working on it to get it into Azure SQL Database. Quick summary. I'm going to get you out of here probably about 5 minutes early. IQP is a game changer. If you saw my colleague Joey's session yesterday and this today, hopefully you can see where these features can help you increase performance with very minimal intrusion. You enable the feature, you enable the database scope configuration, and off you go. You might need a trace flag, as Erlen had mentioned earlier, for the lightweight query profiling. Compatibility levels are important. If you're not familiar with what compatibility level your database is running, you actually might be surprised. I've actually gone into customer environments and they're running fairly new 2017, 2019 in their environments. They're super happy about it. They've been migrating their databases from 2012, 2008 R2. If you're not familiar, if you migrate a database copy or a backup restore to one instance to another, SQL Server is not going to increase your compatibility level. You might be surprised. You might have databases that are set really, really old because Microsoft doesn't want to break your database. That's up for you to do. Yeah. So go look and see what your compatibility levels are, because you actually might be surprised. I do have a client that are running 2019 that we migrated them to, and they forgot to change the compatibility, and they had done exactly that. Over the years, they migrated from 2008, which is compatibility level 100, 110, and they could have gone all the way up to like 150 and take advantage of these new features right out of the gate, and they failed to do that. And we had to go figure out why that performance sucked, because they were still stuck way back in 2008 mode. Really, these features are all about me and me being lazy. I like to fix things with as minimal effort as possible. And so if I get increased flexibility, it's a win for me, it's a win for my clients, because it's not intrusive. And if it breaks something, there are times where this feature might break things, you disable it. It's an easy thing to roll that change back without having to redeploy the entire application. This fixes that. That helps fix this. Because I remember back in the day where we had to make a change and we rolled out the entire application because I told them to change something. But of course, somebody told me or forgot to tell me one key component, and we had to roll all that back. And that deployment was hours long, right? I can make things flexible and fix things very, very easily. Minimal intrusion. I love this. 5 minutes. With that minimal intrusion in these features, if you remember before that I don't want to make code changes, I can now actually say bye-bye to those bad anti-patterns. They can still exist. I don't have to worry about them. I have to spend less time worrying about them because these features, these IQP features, helps negate those bad anti-patterns. Doesn't mean you shouldn't fix them, but it makes my job as a DBA much easier, again, because I can fix them without doing a whole ton of work. With that, I'm going to get you out at 5 minutes early on the dot. My slides are here. Take a screenshot. There's stickers, business cards of myself and my colleague Monica, if you enjoyed her session earlier on performance checklist. Find me on my contact information. I'm always open for questions. Since I am the last speaker, I get to hang out. So I will be up here until everybody leaves. And that's all I got. Any questions? Yeah, quiet bunch, all right? That's it.